Hello people, so today we'll be solving LeetCode daily question 1458, which is max product of two subsequences. In this we'll be given two arrays nums1 and nums2. We have to return the maximum dot product between two non-empty subsequences of nums1 and nums2. Basically what a subsequence is, like for example, if we are given this array which is 1, 2, let me zoom in, yeah, which is 1, 2, 3, 4, 5. So the subsequence of this would be either 2, 3, 4, 1, 1, 2, 3, 1, 2, 3, 4, 1, 2, 4, but not 1, 5, 3. It means basically we have to select the elements without changing their relative positions. Like 153 will not be possible because in the original array 3 is appearing before 5, but if we create an array like 153, it is not a subsequence of the array 1 2 3 4 5. Okay, so let's move to the approach for this question. Okay. So yeah, so okay, there's a catch in this question, which is that if for example we have an array, let's say nums1 1, okay, that has all positive integers. That's a 1 2 3 4, okay, 1 2 3 4 and then 5. And there we also have an array nums2 which has all negative integers, -1 -2, okay, -3 -4 -5. Okay, so or it could also be vice versa. So first we will be discussing the edge case for this question, which is this. Okay, let's say we have this array, so in which nums1 has all positive. Okay, let's write it this way, and nums2 has all negative. So in this case, if we'll be going with that approach only, which we'll be doing for the rest of the given cases, that would also work, but the thing is we have to reduce the time complexity. So first we'll be checking for this case. It could be reverse also, like nums1 could be all negative or nums2 could be all positive. So if this is the case, like for example, if the maximum product of the two subsequence from this could be chosen as minimum of nums1 into maximum of nums2. Okay, so this should be the case if either of the arrays is having like for example, if the case would be otherwise, like if nums1 has all negative and nums2 has all positive. Okay, so in that case it should be different. We'll be returning minimum of nums2 into maximum of nums1. This would be the case, but firstly we have to check for this condition. In this case, if except for this, like if we choose minimum of nums1 which is 1 and maximum of nums2 that is -1, this would be the only way in which we can get the maximum product. You can try, like if we choose 2 and let's say if we choose 1 and -2, we'll be getting -2, which is less than this. If we choose 2 or let's say -3, we'll be getting -6, which is obviously less than 3. So this is the edge case for this question, and to avoid extra calculations, we'll be firstly checking for this test case or this case. Okay, so if we'll check, I guess, yeah, let's put it here. Okay, so now let's check for the approach. Firstly we'll be checking for this case. Okay, let's have nums1 max nums2 max, 2 max, nums1 min, and nums2 min. Okay, wait a second. Yeah, nums2 min. If this is the case, and after finding maximum and minimum from nums1, and similarly, okay, let's do it only. Max of we'll be finding maximum of nums1 using a for loop, minimum of nums1 similarly using a for loop, and similarly maximum from nums2 and maximum from minimum from nums2, sorry. Okay, and then we'll be checking if maximum of nums1 is less than 0. This means that nums1 has all negatives, and minimum of nums2 is greater than 0. This means nums2 has all positive, so we'll just be returning nums1 max. Okay, let's write here nums1 max only. Nums1 max and nums2 min. We'll just be returning nums1 max into nums2 min. Similarly, for the other test case, let's say nums1 min is greater than 0 and nums2 max is less than 0. What we'll be returning nums1 min into nums2 max. Okay, so this would be the case which we have to check first. Okay, now let's talk about what exactly they're talking as they're calling as a dot product. Dot product would be like, let's say in this example, okay, yeah, let's say in this example we have to maximize the dot product, which says we have to select two indexes. Let's say nums1. I'll directly write the value as they are non-repeating, so there would be no confusion. Let's pick up 2 from nums1 into, let's say, 3 plus the dot product basically means we have to choose two indexes from both the arrays, and then we have to move to the next indexes, and we have to add the product of the next indexes. Let's say 1 and 0, 1 into 0. Okay, or otherwise we can also skip this one and we can directly move to -2 also. Using this, we have to find all the subsequences and then out of all the subsequences we have to find the maximum product. And also there could be a possible way like we don't choose any of the other, we just multiplying 2 and 3 gives us the maximum product. This could also be the possible case. Okay, so now this question is a hard level dynamic programming question, and firstly we'll be trying to solve it using uh, top-down dynamic programming, which is basically memoization. So as it is memoization, we'll be needing a okay, yeah, we'll be needing a DP array. Okay, yeah. So we'll be having a 2D DP array. Okay, let's declare it globally only, or we can, okay. And then we have the function What's the name of the function? Max dot product. Okay, max dot product, which takes the parameters as nums1 and nums2. Okay, so in the maximum dot product, first we'll be checking for this case. Okay, so yeah, let's copy paste directly this. This we can find simply using the dot product. Okay, using the for loop, sorry, not the dot product. This we can find using directly the for loop. And then what we have to do, we have to initialize the dp array as dp would be of size nums1 dot length into nums2 dot length. Okay, and then we'll just be calling the recursive function, let's call it solve, and that we'll be passing the starting indexes for both the arrays. Let's start from 0, and in the other like this is the index for nums1, this is the index starting index for nums2, and then we'll be just passing the arrays nums1 and nums2. Okay, now let's write the solve function. Okay, now let's write the solve function. It takes the parameters as int I. Okay, I'll write in brackets that this is the starting index for nums1. Okay, and similarly int j for nums2, starting index for nums2. Basically I'm just writing for nums2, and then nums1 and nums2. Okay, this is yeah, nums2, and then we'll be writing the basis that say that if I is equal to num length of nums or j is equal to length of nums. We'll just be returning 0 because in that case the subsequences from either of the array might not have been chosen. We'll be simply returning 0 in that case. Okay, so and we'll also check that if okay, it's overlapping with this, let's put it here. Okay. And then we'll be checking if dp I j is not equal to 0, we'll be just be returning dp. Okay, there might be the case where we'll be having okay, short, okay, let's do it by this one. Yeah. Okay, then we'll be basically having three choices. Like we'll be having choices that we choose this and this both, or we choose this and this, or if we choose this or this. So we'll be having we'll be we'll be having three choices. Let's wait and okay, three choices could be picking both the index which we are passing through the okay, this would be the first. Okay, three choices. Yeah, this would be the first one, picking both the indexes which we are passing in the function. Second would be skipping the starting index from nums1, and third would be skipping the starting index from nums2. Okay, these could be the three possible choices. So we'll have to consider all these. Let's do, if we do this, let's say we are using both, and let's call it both. Okay, in that case we'll be having nums1 into I, nums1 of I into j of nums2, and then we'll be again calling the recursive function, that is solve, and we'll be incremented both I plus 1 and j plus 1 and nums1 and nums2. Okay, so and then other possible case would be we have skipped from nums1. Let's call it skipped from nums1. In that case we'll just be calling the function, let's call it solve, I plus 1, and we'll not be incrementing the j, and then nums1, nums2. Okay, and then we'll be we are skipped from nums2. So in that case also we'll be again calling the recursive function, that is solve. In this case the I will not be incremented, we'll just be incrementing j and nums1 and nums2. So after this function we'll be like dp of ij would be equal to maximum of both, and then skipped from nums1 and skipped from nums2, and then we'll be just be returning dp of ij. This will provide us with the maximum possible answer. Okay, here we'll be calling, okay, we just be calling this, yeah. So yeah, this should work. Now let's move to the coding window. So firstly, as I have already told, that we'll be checking for this case. So let's have two variables, that's four variables basically. Let's call them max of nums1 equal to is the maximum. Let's give it minimum value, integer dot min underscore value. Similarly, we'll be having minimum from nums1. Let me, okay, why its size is not increasing? Yeah. Okay, is this the maximum size that I can get? I guess this should be visible. Yeah, okay. So this should be visible, and let's give this the maximum value. Then we'll be having maximum from nums2. Let's again give it the minimum value. Min underscore value. Okay. And similarly, we'll be having minimum from nums2. And let's give it maximum value. Okay, so now it is, yeah. Okay. So now we'll be using a for each loop, then for traversing, for let's call it int num in nums1, and max of nums1 would be equal to maximum of max nums1 and num. Similarly, we'll be using this for loop only for finding the minimum value, would be equal to math dot min of min nums1 and num. Okay, so similarly we'll be finding the minimum and maximum from nums2 and nums2. Okay, so max of nums2 would be equal to okay, let's do it here also. Minimum of nums2 would be equal to yeah, math dot maximum of max nums2 comma num, and okay, I'll just changing this. Okay, this should be min, and here also it should be min. Yeah, so after doing this, I'll just be checking that if nums1 max is less than 0 and nums2 min is greater than 0, we'll be just simply returning nums1 max into nums2 min. Okay, and similarly for the other test case, if nums1 min is greater than 0 and nums2 max is less than 0, we'll just be returning nums1 min into nums2 max. Okay, so this was the case. Now let's initialize a dp array. Let's call it int dp, and here we'll be initializing it. Let's call dp is equal to new int nums1 dot length nums2 dot length. Okay, and now let's call the solve function nums1 and nums2, and we'll be just be writing the recursive function solve int I comma int j comma int nums1 comma int nums2. So firstly we'll be writing the base case, that is that if I is equal to nums1 dot length or j is equal to nums2 dot length, we'll be just be returning 0. And then if dp of I j is not equal to 0, we'll just be returning dpij. Okay, then we have to write the case in which we are choosing the both. Let's call it both, then that will be nums1 I of nums1 into j of nums2, plus we'll be calling the recursive function again, that's I plus 1, then j plus 1, then nums1 and nums2. Now let's initialize another variable. Let's call it skipped from nums1. In that case, we'll be just be calling the solve function without changing the value of j, I plus 1 comma j comma nums1 comma nums2. and then similarly int skipped from nums2 will not be incrementing I, will just be incrementing j, and nums1 nums2. Okay, and then we'll be doing dp of ij would be equal to math dot max of both, and then math dot max of skipped from nums1 and skipped from nums2, and at the end we'll be just returning dp I j. It's okay, it's saying error. Okay, let me check the error. Okay, it cannot find the symbol. Oh, okay, it's max of. Oh, okay, I just made a mistake over there. It's like this of a max of nums1 and min of nums2. So what we'll be returning, will be returning max of nums1 into min of nums2, then max of nums2 into min of nums1, and here also max of nums2 into min of nums1. Okay, yeah. So this worked. Okay, yeah. So this is accepted, and yeah, this works well. But if we want, okay, so basically the time complexity for this would be O of n into m, and space complexity for this is O of n into m, because we are using a 2D DP array of length nums1 and nums2, and time complexity will be O of n because we have to calculate all the possible subsequences which are possible. But if we want to do this with the tabulation approach, so we can do that also. So in tabulation, firstly, this would be the this one would be the standard in all the cases. This we have to check for whether we are doing tabulation or memoization. This would remain constant across all the three. And the next step I'll be also be doing the space optimization. This would be the base case. This would be the edge case, and this we have to check in every possible in the every method which we'll be doing. This would be the first thing we'll be checking, and then okay, I'll be writing the case for the next one. If okay, then here we'll be declaring a DP array of size nums1 dot length +1 to make it one based indexing, and no, not one based indexing, but because we'll have to find the answer will be stored in this like okay, let's make a table if it is possible. Okay, no, it's the port 2. Okay, so let's make a table this way only. So as this is bottom of DP, so the answer solution would be moving somewhere like this to this. So we have to start from this index. Okay, So yeah, that's why dp of nums size nums1 dot length plus 1 and nums2 dot length plus 1. Okay, so now we'll be starting from int I equal to nums1 dot length. We'll be starting from the last 2 while I is greater than equal to 0, and we'll be doing I minus minus. Similarly, another for loop for int j equal to nums2 dot length, 2 dot length, j greater than equal to 0, j minus minus. Okay, so what we'll be doing, we'll be again be having the 3 choices that we have to choose the current. We have to choose both the indexes. Like in this we have to choose this and this both, or the other choices we can do this and this, or the other choices we can do this and this. Okay, similarly in this also we'll be having the 3 choices. So if we choose both, what we'll be doing, nums1 I into nums2 j plus dp of I plus 1 and j plus 1. Okay, and similarly if we will be having the choice from skipped from nums1, what we'll be doing is that we'll do dp of I plus 1, and in that case j would be same. Okay, and in the other choices we have from skipped from nums2, then we'll be having dp of I as it is, and then dp of j plus 1, and at the end we'll be storing dp of I j equal to max of both, and skip from nums1 and skipped from nums2. Okay, and at the end we'll be just be returning dp of 0 and 0, because as I already told that this is a bottom-up dynamic programming approach. So we'll be traversing in the table like this. Let's not this. So let's say this is our DP table, and we'll be starting from here. And after finding the maximum value, our answer will be stored at this, and this is the index 0, 0. Okay, let's write it properly. And this index is 0, 0. Okay, so that's why we are returning dp 0 of 0, 0. So let's move to the coding window once again, and let's copy this path, because this would be same. Okay, let's copy up till here, and then okay, yeah, here just we have to initialize the dp with nums1 dot length plus 1 and 1. Okay, here we have to do int dp 2d array. Yeah, so then we'll be initializing the for loop for int I equal to nums1 dot length I greater than equal to 0, I minus minus. Similarly another for loop int j equal to nums2 dot length j greater than equal to 0, j minus minus. So in this also we'll be having three choices. Let's call it, okay, let me zoom in first. Yeah, I and t, let's say we have picked up both, then nums 1I into nums 2j plus dp of I plus 1 j plus 1, and then we are having choices of skipped from nums 1. Okay, we'll be just be doing that in the max function. dp of I j should be equal to dot maximum of both, and then maximum from dp I plus 1, dpi, okay, dpi plus 1 and j comma dp of j I j plus 1, and at the end we'll be just returning dp 0 comma dp of 0 0. Okay, it's giving an index out of bound exception. Okay, oh sorry, here the loop will be initialized by I minus 1. Yeah, okay, so this is accepted. Yeah, and okay, so this one's also accepted. So the time complexity for this and space complexity for this is also same as the previous one. So time complexity for this is of n into m, because we are running two for loops from n minus 1 to 0, and similarly from m minus 1 to 0. And space complexity for this is also n into m, because we are using a 2D DP array of size n plus 1 and m plus 1. But now let's move to the third thing, which is when we can have a space optimization for this. Okay, so again that this case would be same. We have to firstly check for this, that is constant throughout all the three cases. Okay, so this is the first thing which we have to check again. Now we'll be, for this space optimization, we'll just, as we can see that we are needing the values from which we have previously calculated. Like if we go from like I minus 1, which would be the, okay, in this only I'll explain that to calculate this value we are needing this value, I plus, we are needing this value and we are needing this value. So, and similarly for this we are needing this value and we are needing this value. Similarly for this this position we are needing this value and this value. So what we can do is, we can, instead of storing all the values, we can create a new we can have two dps of size m plus 1, nums 2 dot length plus 1. Okay, so this case would be the same across both the things. And now let's have a dp of size, okay, dp of size nums 2 dot length plus 1. And now let's have a dp, let's call it prep, also of the size nums 2 dot length plus 1. Okay, so now we'll be running a for loop, I equal to nums 1 dot length to minus 1, basically minus 1 to I greater than equal to 0. And similarly another for loop, j equal to nums 2 dot length minus 1 to j greater than equal to 0. Okay, so what we'll be doing both. Again, we'll be having three choices to choose both, or we can choose skip from the first array, that is nums 1, and we can pick the same the index from the second, and the vice versa case. So what we'll be doing, we'll be choosing both, and for that what we'll be doing nums 1 I into nums 2 j plus prev j plus 1. And similarly we'll be having the choice of skipped from skipped from nums 1. In that, what we'll be doing the I would not change, so prev of j. And if we skip from nums 2, we'll be just doing prev, we'll be just be using the previous value from j. Okay, what this basically do is, let me explain that what's this doing is, you can see that when we are choosing, okay, let me explain it here only. Yeah, so let's say this is our DP array from the last bottom up approach. Okay, so for this index, what we are basically doing, we are in the same row but in the another column. Okay, for this index we are doing I plus 1 and j plus 1. But if we do a previous array, let's say this is our current DP, and then let's call this one as prev. Okay, now let's make some partitions. Yeah, and this is our prev DP. Okay, so if we are skipping from nums 1, what we can do is we can just simply put, for this particular index, let's say in this case we are skipping from nums 1, we are not going to the next row, we are just picking up this similar from j. Okay, so here we are storing this value, and if we are skipping from nums 2, then we are storing j plus 1, that is this value. So this is what we are doing in this space optimization. Okay, and at the end again dp I would be equal to max of the three, maximum of both, and then skipped from nums 1 and skipped from nums okay, second, yeah, skipped from nums 2, and at the end what will be returning dp of, oh, and after this for loop what we'll doing, we'll be making prev equal to dp. Okay, and one thing I skipped, that here we have to reinitialize the dp to dp of size nums 2 dot length plus 1. Okay, here it is fine. Yeah, and at the end of all these things will be returning dp of 0. Okay, so now let's move to the coding window once again. Let me copy this once again, because this was the standard thing which we have to do in all the three cases. Yeah, just simply paste this. Okay, now let's create two dps. Let's call it int dp equal to nums 2 dot new int nums 2 dot length plus 1, and similarly we'll be having a dp called prev equal to new int nums2 dot length plus 1, and then we'll be initializing a for loop I equal to nums1 dot length minus 1, I greater than equal to 0, minus minus, and then for int j equal to nums2 dot length minus 1, j greater than equal to 0, j minus minus. So similarly we'll be having three choices. Let's call it int both. For that, what we'll be doing, nums1i into nums2j plus prev of j plus 1. And then what we'll be doing, dp of I would be equal to math dot maximum of both, and then again math dot maximum of prev j comma prev of j plus 1. Okay, and after this we'll be prev equal to dp, and here we'll be reinitializing dp equal to new int nums2 dot length plus 1, and here what we'll be doing, we'll just be returning dp of 0. Okay, the mistake I made. Let me go through the code once again. And nums2 dot length minus 1, nums I nums j dp of level j plus 1, then dpi is equal. Okay, sorry, here it should be dpj. Okay, now this is still giving me an error. The possible error, prev is equal to dp nums1 I into nums2j plus prev of j plus. Okay, what's this case? It's not having all negatives. Okay, and dp of length nums2 dot length plus 1, and similarly prev of the same length. Then for int I equal to nums1 dot length minus 1, I should be greater than equal to 0, I minus minus, then initializing the dp array again, then for loop for int j equal to nums2 dot j greater than equal to 0, j minus minus. Then we have the choice to choose both prev. Okay, sorry, here it should be dp of j plus 1. Yeah, now it works fine. Okay, so in the here also, yeah, I made a mistake. It should be dp of j plus 1. So let's get back here. Yeah, and it is accepted. So this was it for today, and we'll be doing the same for tomorrow. If you want to follow, you can follow me on Instagram. It's Kabir Coding. There I am posting reels related to Haskell, data science, machine learning, and we also tidbits from DSA. Thank you for watching.